Welcome to our deep dive. We're going to be talking about something pretty amazing today.
Ocean current energy.
Yep, you know those wind farms you see? Like, everywhere.
Right.
Imagine those, but underwater.
Yeah. Harnessing the power of the ocean.
To light our world. It's pretty mind-blowing when you think about the scale of it.
It really is. I mean, we're talking about potentially meeting 10% of global electricity needs.
10%?
Yeah. That's enough to power something like 400 million homes. Could you imagine 1 in 10 houses getting their electricity from the ocean?
That's a lot of houses.
It is. And, it's not just some small-scale experiment either. The ocean is powerful. And ocean currents, they're remarkably consistent.
Right. They don't stop like the wind.
Exactly. It's a source of power that's always on.
Always on. Okay, so you shared a bunch of research with me on this, and I have to say, I'm pretty excited to dive into this.
Me too.
We're going to be talking about everything from underwater turbines, kind of like those giant windmills we were talking about, to buoys, to this crazy idea of using the difference in saltiness between seawater and freshwater to generate power.
Yes, salinity, gradient energy. It's pretty wild.
It is. Plus, we'll look at the economics, the future of it all. So should we start with underwater turbines?
Sure, let's start there.
Okay, so basically giant wind turbines, but submerged. I was reading that water is 800 times denser than air.
It is.
Which means even slow ocean currents can generate a lot of energy.
You got it. That density is key. And we're already seeing this in action, like the Machen project in Scotland. They're using tidal currents, which are basically super strong ocean currents, to power over 2,600 homes.
Already. That's amazing. But I have to ask, because these turbines are deep underwater, right? How do they maintain them?
It's definitely a challenge.
Saltwater's corrosive, it's dark, there's all that pressure.
All true. But engineers are coming up with some pretty clever solutions. They're developing special coatings to protect the turbines from corrosion.
Okay.
And get this, they're using autonomous robots for maintenance.
Robots, like R2-D2 going down to fix things.
Well, maybe not R2-D2, but yeah. Robots. So we don't have to send divers into those dangerous conditions.
Wow, that's pretty impressive. Okay. But I've also heard people are worried about the impact on marine life.
It's a valid concern.
Yeah. I mean, those are some big structures moving in the water.
For sure.
Yeah.
But, we learned to build bridges that birds wouldn't fly into.
Right.
Same principle here. The newer turbines are designed with slower-moving blades, sonar systems.
To do what?
To keep animals from getting too close. It's all about technology and nature coexisting.
So like underwater traffic signals for fish.
Exactly. And there are projects out there that are showing it can work. Verdant Power, they have this installation in New York City's East River.
Okay.
And they've shown these turbines can operate without harming the fish.
So it's about responsible development.
Absolutely.
Cool. Okay, let's move on to another technology that I was reading about. Buoys.
Oh, yeah.
I understand that buoys can harness energy from both the up and down motion of waves and from the steady flow of ocean currents, which is amazing.
It is.
And I was reading that, a single buoy can power quite a few homes.
It really can. The Wave Roller project in Portugal, they have this buoy system that captures the energy of waves as they roll in. And get this, with a single buoy, they can power 100 homes.
So each buoy is like a mini power plant bobbing out there on the waves.
You got it.
That's really cool. So are there any other, new advancements on the horizon when it comes to buoys? What are you excited about?
Plenty. There are researchers looking at these really interesting materials, piezoelectric materials.
Piezoelectric materials. What are those?
They can actually convert pressure into electricity.
So if you squeeze them, you get a little zap of energy?
Yeah. Something like that. Plus, we're using AI to figure out the best spots to put these buoys.
To catch the most energy.
Yep. It's all about optimizing placement for efficiency.
So it's like finding the perfect oceanfront property for your energy-generating buoy. Okay, but I'm thinking, could you combine turbines and buoys into one super system?
You're thinking hybrid systems.
Hybrid systems.
Yeah, and they're actually being developed right now. The idea is to have turbines harnessing energy from those ocean currents.
Okay.
And buoys capturing the wave energy. A double dose of power.
I love that idea.
Right.
And I can see that being especially useful in places where you have, both strong currents and big waves.
Absolutely. Like Japan, think about their coastal areas. They experience both.
Yeah.
So they'd be an ideal location for a hybrid system. It's all about tailoring the technology to the environment.
That makes a lot of sense. Okay, so now for this one. It's called Salinity Gradient Energy, or blue energy.
It's a mouthful, I know.
It is a mouthful. It sounds pretty futuristic, though.
It is. And it's based on a pretty simple principle. The difference in salt concentration between seawater and freshwater.
Wait, so you're telling me you can get energy from salty and freshwater mixing?
You can.
What?
Think of it like this. When seawater and freshwater meet, like at the mouth of a river, there's a natural energy difference between them. We can capture that difference
Right.
and use it to power a generator,
So you're tapping into nature's battery.
basically. And we already have examples of this in action. The Afsluitdijk plant in the Netherlands,
The what?
the Afsluitdijk plant, it uses a process called reverse electrodialysis
Okay.
to generate electricity from the mixing of seawater and freshwater.
That's incredible. But I'm guessing there are challenges in scaling this up.
You're right, it is a challenge. We need very specific conditions, and the membranes, which are a crucial part of the process, need to be really durable.
To handle the ocean environment.
Exactly.
So it's a bit more location specific than turbines or buoys.
It is.
Okay. So it sounds like there's still a lot of research and development needed for this one.
Yeah, but the potential is there. Right now, the efficiency is around 20 to 25%, but with ongoing research, that number could go way up.
So there's hope for the future.
Oh, for sure.
All right. So we've talked about all these ways to capture energy from the ocean, but then how do we actually get the electricity back to shore?
Haha, good question. It's not like we can just plug an extension cord into the ocean floor.
Right. It's a good point.
Yeah, it takes some clever engineering to get that power back to land. We have to design generators that can work perfectly in a really tough environment.
Yeah, I can imagine. You're dealing with waterproofing, corrosion, the constant movement from the waves and currents, pressure.
It's a lot to consider. But engineers are coming up with some really innovative solutions.
Yeah.
One example is direct drive generators.
Direct drive generator.
Yeah, they're designed specifically for these conditions. And they're much simpler in design, which means fewer parts that can break down.
Less maintenance.
Exactly.
Okay, so simpler is better in this case.
It is. It makes the whole system more reliable and affordable.
That makes sense. So they're basically building these generators to be as tough as the ocean itself.
Pretty much.
I love that. Are there places where they're like really pushing the boundaries with this tech?
Oh, absolutely. There's the European Marine Energy Centre in Scotland, or EMEC. They're constantly testing and refining generator designs for ocean energy. It's like a testing ground for all sorts of wild, innovative ideas.
That's so cool. So speaking of testing, let's talk about cost. How does ocean energy compare to like wind and solar?
That's the big question. Right.
It is. I mean, we all want to know how this will affect our wallets.
Right. Well, right now, ocean energy is more expensive than wind or solar. It's about $0.30 to 50 cents per kilowatt hour for ocean energy, compared to about $0 and $4.10 for wind and solar.
So there's definitely a gap there.
There is.
But is there hope that it will come down in the future? I mean, weren't solar panels super expensive once?
Exactly. Solar was very expensive. But over time, as the technology improved and production scaled up, the costs came way down. I think we'll see the same thing happen with ocean energy.
So as the technology develops, it becomes more affordable, more accessible.
That's the hope.
That's good to hear. But what's being done to help close that cost gap right now?
Well, we're seeing a lot of positive action from both governments and private investors. The European Union's Horizon 2020 program, for example, has invested over $80 million in various ocean energy projects.
Wow, that's a lot of money.
It is. And in the United States, there are collaborations between the Department of Energy and companies like Ocean Power Technologies. They're all working together to advance the technology and bring those cogs down.
That's really good to hear. Are there any particular policies that could really help make ocean energy more widespread?
One of the most effective policies is a feed-in tariff. It guarantees developers a fixed price for the renewable energy they feed into the grid.
So a guaranteed return on their investment.
Exactly, which encourages more investment.
Okay. Well, I think we've covered a lot of ground here today.
We have.
We talked about the incredible potential of ocean energy, the different technologies, the challenges, the opportunities.
Been a good overview.
It has. But before we move on, I'm really curious about your thoughts on the future of this. What advancements are on the horizon that could, really change the game?
Oh, I think we're on the verge of some really groundbreaking stuff. We're going to see major advancements in material science.
Like what?
The use of graphene, for example, to create super durable and efficient turbines. We'll see those modular designs we talked about earlier, making things easier to build and maintain. But perhaps the biggest change will be the role of artificial intelligence.
AI in ocean energy.
Yeah. Imagine AI systems that can analyze ocean currents and wave patterns in real time, predict the best locations for energy capture.
So we're basically giving these systems a brain.
You could say that,
Hmm.
allowing them to learn and adapt to the environment.
That's incredible. So with all these advancements, do you think ocean energy could really become mainstream one day?
I do. I think with continued innovation, investment, and collaboration, ocean energy could be a major contributor to meeting global renewable energy targets by 2050. It's an ambitious goal, but I think it's possible.
That's a powerful vision for the future. And you know what? I think you just gave me an idea for a future episode.
Oh.
We've talked a lot about the technical side,
Yeah.
but I think it would be fascinating to explore what a world powered by ocean energy would actually look like.
Like, what would that future be?
Exactly. Imagine coastal cities drawing their power from the waves crashing on their shores. It's a pretty incredible thought.
I agree. It's not just about the technology. It's about the possibilities it opens up.
I like it. That's a great place to pick up in our next episode.
Sounds good to me.
So until next time, keep exploring this world of ocean energy because the future's bright and it's powered by the ocean.
Couldn't agree more.
Welcome back to our deep dive into ocean energy.
Riding that wave of excitement.
We are. Before we went on that tangent about cities powered by waves, we were talking about some really cool advancements in ocean energy.
Oh, yeah. Things that could make it even more efficient, more affordable.
Right. Like that graphene stuff you mentioned. I have to admit, I'm still not quite sure what it is.
Well, imagine a single layer of carbon atoms arranged in this honeycomb pattern.
Okay.
That's graphene. And it's incredibly strong, something like 200 times stronger than steel.
Stronger than steel. Okay, now you have my attention.
It's pretty amazing stuff. Now think about those underwater turbines we talked about.
Yeah.
They're constantly exposed to salt water.
And salt water eats away at everything.
It does. Boats, docks, even your beach umbrella will rust eventually.
Exactly.
But imagine coating those turbines with something even tougher than steel, something that just laughs at saltwater corrosion. That's graphene.
So it's like giving those turbines a suit of armor.
Yeah, a suit of armor protecting them from that harsh ocean environment.
I like that. But it's not just about protection, right?
Right. Graphene is also a fantastic conductor of electricity.
Yeah.
So you lose less energy during
You
transmission.
get more bang for your buck.
Exactly. So graphene, it's a game changer for these underwater turbines. Makes them last longer, work better.
That's really cool. What other, surprising materials are they looking at in this field?
There's a lot of excitement around materials that can actually generate electricity from movement or pressure.
Wait, what?
Yeah. Think about how much movement there is in the ocean. Waves crashing, tides going in and out, currents swirling around. What if we could capture that energy directly?
That sounds like science fiction.
It kind of is.
Yeah.
But it's becoming reality. One example is piezoelectric materials.
Piezoelectric, that's a mouthful.
It is. But remember that analogy I gave you about squeezing a crystal and getting a zap of energy?
Yeah.
That's the basic idea. These materials generate an electrical charge when you put stress on them, mechanical stress.
So you could have a buoy that generates power just from the waves pushing and pulling on it.
Exactly. And as these materials get better, more efficient, we could see a whole new generation of ocean energy devices.
Ones that are even better at harnessing that power of the sea.
Exactly.
Wow, I'm starting to see why you're so excited about all this.
It's pretty cool stuff.
Yeah.
And it's not just the materials themselves, it's how we design these systems.
Right, like those modular designs we talked about.
Yes. Remember, the Lego block approach.
Yeah, like building underwater turbines with Legos.
Well, that same idea can be used for all sorts of ocean energy devices.
Really?
Yeah. Imagine building a wave energy converter out of standardized parts that you can easily put together and swap out.
So instead of building one massive thing, you're creating it out of smaller pieces.
Exactly, like a giant underwater Lego set.
Okay, that image definitely helps.
Good.
But wouldn't that make it, weaker, having all these separate parts?
Not really. These modules can be designed to interlock, to reinforce each other.
Okay.
Think about bridges. They're made up of individual sections, but they work together to create a strong, stable structure.
That makes sense. But what's the real advantage of this approach?
It's about making things easier. Easier to build, easier to maintain, easier to scale up.
Okay.
You can make these modules in a factory, ship them out to the site, and then just snap them together underwater.
Wow.
And if something needs repair, you just swap it out with a new one.
So it's a very flexible system.
It is.
That's really smart. So these modular designs, they could really help make ocean energy more practical.
Absolutely.
More affordable.
Right. But there's another piece to this puzzle, and that's data. We talked about AI and how it could optimize energy capture.
No, yeah, I wanted to hear more about that.
Well, the ocean, it's constantly changing, right?
Yeah, it's not like a wind farm where you just stick a turbine in a field.
Exactly. And that's where AI comes in. AI can analyze all that data about currents, wave patterns, tides, weather, even marine life activity
In real time.
in real time. And then it can identify the best locations and times for energy capture.
So it's like having an AI oceanographer on staff.
Uh-huh, yeah. Making sure those devices are always in the sweet spot for energy production.
That's pretty amazing. Is there anything AI can't do?
Well, let's not get carried away.
Fair enough. But this is just the beginning for AI in ocean energy, right?
Absolutely. We can use it to predict maintenance needs, optimize how we integrate with the power grid, even design better devices.
It's crazy to think how much potential there is.
It is.
Okay, so we've got new materials, modular designs, the power of AI. It all sounds amazing. But what are the challenges? What are the risks?
That's a good point. It's important to be realistic. One of the biggest challenges is just the unpredictable nature of the ocean itself.
Storms, currents, marine life.
All of that. We have to design these systems to be super resilient.
Able to withstand pretty much anything.
Yeah. Able to withstand the forces of nature and still keep working efficiently.
So it's not like building a power plant on land where everything's nice and controlled.
It's not.
It's more like building a house on the coast.
Exactly. You have to factor in hurricanes, strong winds, all of that.
But we've learned to build structures that can handle those things.
And we can do the same with ocean energy devices. But we also have to think about the environmental impact.
Right. I know people are worried about harming marine life.
And that's a valid concern. We need to carefully study the potential impacts from the noise these devices make to how they might interact with animals.
So it's not just about building these systems.
Yeah.
It's about building them responsibly.
Absolutely. We need to find ways to minimize any negative impacts. Designing quieter turbines, using lights that don't disrupt nocturnal animals, choosing locations that avoid sensitive habitats.
So a lot of research and planning.
A lot. We need to get this right. We need to balance harnessing this power with protecting the ocean.
Because ultimately, a healthy ocean benefits all of us.
That's right.
Welcome back to the deep dive.
Ready to wrap up our ocean energy journey?
I am. You know, we've talked a lot about the theory, the potential.
The what ifs?
Yeah, the what ifs. But I think it's even more exciting to see how this is all playing out in the real world.
Absolutely. Seeing is believing, right?
Exactly. So in this final part, I was hoping we could dive into some actual projects.
See what's happening out there.
Yeah, and get a sense of how this is all coming together.
I'm happy to share some examples. In fact, we've already talked about a few.
Oh, yeah.
Remember that trip to Scotland we took? The European Marine Energy Center, or AMEC?
EMAC, the Silicon Valley of Ocean Energy.
That's one way to put it.
So what kind of cool stuff are they testing there?
All sorts of cutting-edge designs. They have these massive underwater turbines, like giant windmills under the sea.
Wow.
And then there are wave energy converters that look like giant sea snakes bobbing on the surface.
Sea snakes. Okay, now I'm really intrigued.
They're pretty wild. Imagine a long, flexible structure moving with the waves.
Okay, I'm picturing it.
And inside, there are these hydraulic systems that convert that up and down motion into electricity.
So they're kind of riding the waves and generating power at the same time.
Exactly. It's a pretty neat concept.
It is. And it's amazing how we can take inspiration from nature, you know?
Oh, absolutely. Nature is the ultimate engineer.
So Scotland is clearly a hotbed for this kind of innovation. Are there other places that are really embracing ocean energy?
Oh, yeah, there are a bunch. Let's hop across the Atlantic to Canada.
Typical. Yep.
The Bay of Fundy, specifically.
Famous for its crazy tides, right?
The highest tides in the world. The tidal range there can be as high as a 5-story building.
A 5-story building. Okay, now that's impressive.
Imagine the amount of energy in that water as it moves back and forth.
It's mind-boggling.
It is. So what they're doing is installing underwater turbines in a narrow channel called the Minas Passage.
Okay.
It's like squeezing all that tidal energy through a bottleneck, which creates a really powerful current.
And the turbines are right there to catch it.
Exactly. They're strategically placed to maximize energy capture.
It's brilliant. So we've got Scotland, Canada. What about other parts of the world? Is this a global trend?
Oh, absolutely. It's catching on everywhere. Let's head over to Asia. Japan has been a leader in wave energy for years.
Japan, yeah, they have a lot of coastline.
They do. And they have limited space for those traditional power plants, so they're really looking to the ocean.
For clean energy.
Yeah. And they're exploring all sorts of approaches, from offshore devices to systems built right into their coastal structures. They're even looking at combining wave energy with offshore wind farms.
Wow, that's smart.
Right. It's all about making the most of their ocean resources.
And they're not the only ones in Asia doing this, are they?
Nope. China is investing heavily in this area as well.
They're going all in on renewable energy.
They are. They have huge plans to develop tidal and wave energy along their coastline.
It's really exciting to see this kind of global momentum building.
It is.
But ocean energy, it still feels like a relatively new industry.
It is, yeah.
So what's driving this rapid growth? What's pushing things forward?
I think it's a few things coming together. First, there's the urgent need to address climate change,
Yeah, finding alternatives to fossil fuels.
Exactly. People are demanding clean energy, and governments are starting to listen.
So it's public pressure and government action working in tandem.
Yeah, you could say that.
And of course, there's the financial side of things.
Right. The economics are becoming more favorable. Those feed-in tariffs we talked about.
They're making a difference.
They are. They're attracting investors, making ocean energy more financially viable.
And I imagine international collaboration is helping too, right?
Huge help. Countries are sharing knowledge, resources, expertise. They're realizing that we're all in this together.
That's really encouraging to hear. It sounds like we're on the cusp of a new era.
It does feel that way.
But let's be realistic. What could slow down progress? What are some of the roadblocks?
Well, there are always challenges with new technologies. One of the biggest is still cost.
The cost of building these things.
Yeah, ocean energy systems can be expensive to build, expensive to maintain.
So that's a hurdle we still need to overcome.
We do. And then, of course, there's the environmental impact. We have to be very careful about that.
Making sure we don't harm the ocean.
Right. Protecting marine ecosystems, avoiding disruption to marine life, that's crucial. We need ongoing research and responsible development practices to get it right.
It's a balancing act.
It is. Harnessing the power of the ocean while protecting its health.
Well, I have to say, this has been an incredible deep dive.
I've enjoyed it.
Me too.
Yeah.
From those underwater turbines to those bobbing sea snakes to the potential of AI and global collaboration.
It's been a wild ride.
It has, but it's clear that the future of energy is, well, it's pretty exciting.
It is. It's full of possibilities.
So to our listeners, thank you for joining us on this journey into the world of ocean energy.
We hope you learned something new.
We hope we've inspired you to keep exploring this amazing field, because the future is bright and it's powered by the ocean.
Hear, hear.